Good morning, students. Today we are going to discuss on the topic of the chemical corrosion. This is coming from the third module, and I am Dr. M. Vijay Bhaskar Reddy, Associate Professor at Department of Chemistry. So today we discuss about the chemical corrosion. Before going to topic chemical corrosion, we discuss about the some of the definition of the corrosion. So definition of the corrosion. And first one, a definition of the corrosion. Second one, a causes of corrosion. So first one, definition of corrosion. Second one, causes of corrosion. We discuss causes of corrosion. And third one, what are the disadvantages of corrosion? Disadvantages of corrosion. Before going to this topic, these first three topics will be discussed, then enter into the chemical corrosion. You understand easily. Okay, so first we go discuss about the definition of corrosion. So what is the definition of corrosion? The process of decay of metals or alloys by environmental attack is called the corrosion. So means what is this one? The process of decay of metals or alloys, environmental attack is called the corrosion. So what are the units for the corrosion? Generally, the corrosion of the metal is measured in the units of milli-inches in a year or millimeter in a year. Because it's a corrosion is a very slow process, it will be takes years time. So that why we measured in the corrosion product on the metal surface by units of either millimeters in a year or milli-inches in a year. So that is the definition of that one. The process of decay of metals by environmental attack. Whatever environmental conditions like gases, liquids, whatever solids, whatever environmental present in the all will be causes for the corrosion of the metals or alloys is called the corrosion. So first one, that is the definition. The second one is the what is the causes of corrosion. This is a very important mechanism why metals are corroding. Because most of the metals will be available in the earth crust. They in the form of ores. They in the form of ores. Directly metals are not available in the earth crust. So these are all metals will be available in the earth crust is in the form of their ores. Ores is means they're mixed with the oxides, carbonates, hydroxyls, carbonates, sulfates, chlorides, silicates. These are all the ores. For example, you take the iron ore. Iron will be available in the form of Fe2O3. Or aluminium will be available in the form of ore is Al2O3 like the bauxite. Is a lead will be available in the form of lead sulfide, galena. So means these are all metals will be available in the earth crust in the form of their ores. So different metals will be available in the different products like in the form of oxides, carbonates, sulfides, chlorides, silicates. These are all the ores. But these are all ores are thermodynamically stable. Whatever available metal ores is thermodynamically stable. Okay, so once coming these metals, the metals will be extracted from the ores. For example, iron ore is the Fe2O3. So if from the Fe2O3 iron ore, iron will be extracted. So the iron metal will be extracted from the iron ore of Fe2O3. That process is called the metallurgy. Or another name is called the reduction, because the process is called the reduction. Because once the metal will be isolated or extracted from the ore is called the metallurgy or extraction, metallurgy or metal extraction, or process is called the reduction. The isolated metals from the ores, those are thermodynamically unstable. The isolated pure metals from the ores is thermodynamically unstable because they are in higher energy state. because they are in the higher energy or excited state, or in the excited state, or that's why these are thermodynamically unstable. So whatever these thermodynamically unstable metals, they go back to the original position. So means the isolated metals from the ores are they go back to the original position. So original position, that process is called the oxidation or corrosion. Okay, oxidation or corrosion. So because they are for the stability purpose, these isolated metals are once again they go back to the original position of the ores. That process is called the oxidation, or another name is called the corrosion. Okay, this is the natural tendency. They go back to the combined state, thermodynamically stable form. That's why these metals are always unstable. They go back to the original position of their ores. That process is called the corrosion or oxidation. Okay, now what is the causes of corrosion? The isolated metals from the ores are thermodynamically unstable. That's why these metals are once again they revert back or go back to the natural tendency of form the whatever forms of ores is called the corrosion or oxidation. Okay, this is the main causes of the corrosion. So coming to the what is the major disadvantages of the corrosion. So what are the major disadvantages of the corrosion? First one is the all metals having valuable metallic properties. This is the very important. All metals, most of the metals having the metallic properties, the valuable metallic properties, like is the conductivity. Most of the metals are having good conductors, and malleability and ductility. So malleability, ductility means is take whatever form the seeds or thin like threads. These are all will be easily formed the metals. So once these valuable properties are lost, when the metal will be corroded, because once the metal will be corroded, the valuable properties of conductivity will be lost, malleability will be lost, and ductility will be lost. Second one, what are the second disadvantages is there? The process is very harmful because very expensive also, and lot of wastage of metallic products will be takes place. Once the metal will be corroded, the lot of wastage will be takes place. A metallic wastage will be takes place. For example, already in the previous class in the water treatment chapter, so boiler corrosion in detail we discussed. So boiler is nothing but one of the closed vessel that will be widely used for the water is converted to the steam. So boiler is a closed vessel type. In that boiler, water is converted to the steam. That steam utilized for the power generation. So means a boiler is a very important in the generation of the power. So once these whatever water containing the some of the compounds, the boiler will be corrosion takes place. So is a lot of environmental related gases, salts or solids. These are all will be present in the water. Boiler will be corrosion takes place. Okay. So coming to the another important, very important point, when the metal will be corroded, the important metal strength will be reduced. This is the very, very important. That one is the once the metal strength will be reduced. For example, here we discuss what this is the metal. So once the metal will be corroded means some of the rust product is obtained on the surface. So means here the total metal strength will be decreased. Remember that one. The metal strength will be decreased or reduced. Metal strength will be reduced. Once the strength will be reduced, the total machine efficiency will be reduced, because total machine efficiency will be depend upon the total metal. So the strength is reduced means machine efficiency will be reduced. This is that's why very important in the industries. So because another point, because this is a very expensive research area also, because in the worldwide more or less almost $2.5 billion per annum are spending for the corrosion research, because it's the most of the metals or alloys used for the industry construction. Without metals or alloys, you construct the industries is very difficult. That's why this is a very expensive research area, and more or less almost $2.5 billion of money is spending for the corrosion research. Okay, these are the disadvantages. First is the metallic properties and the strength and wastage or whatever fabrication. These are all will be these are disadvantages of the once the metals or alloys are corroded. Okay, so these are first definition we discussed, causes of corrosion discussed, and disadvantages of the corrosion discussed. So I will show the two case studies happen in the previous years. So due to the corrosion, the first one in 1988, one of the 19-year Boeing flight will be operated by Aloha Airlines at the feet of the 24,000 feet. So due to the some of the small crack happened by the corrosion, small crack will be happened by the corrosion. The total roof of the flight will be damaged at the feet of 24,000. So this is a corrosion is a small point, but its damage will be enormous. Remember that one. Is the damage is enormous. Damage is a more. Corrosion is a small. It looks like a small topic like, but is the damage is very more, very high. This is the one case study. Another case study we discussed, that one is already happened in India. That is the Bhopal gas leakage. This also is a causes one of the corrosion. Whatever pipes is carried out, one of the is a compound methyl isocyanate. That compound is carried pumped through the some of the iron pipes. That iron pipes will be some of the leakage takes place. That gases will be leakage happen in the December 3rd, 1984. This gas will be widely used for the preparation of urea manufacturing. So that gas is leaked. So a lot of people are dead, a lot of people are suffered. Now still is most of the people is suffered with the cancer, eye irritation, lung cancers in the Bhopal. Still is this case is going on in the Supreme Court. Not clear. Okay, this is another instant or case study whatever related to the corrosion. Okay, coming to another one. We go to the topic of the chemical corrosion. Chemical corrosion. So mainly there are two types of corrosion theories will be explained. First is the electrochemical corrosion or dry corrosion. Chemical corrosion or dry corrosion. Second one is the electrochemical corrosion or wet corrosion. In that we discuss this topic in the today class, and the next class in depth we discuss about the electrochemical or wet corrosion class. So today chemical corrosion or dry corrosion. So what is the chemical corrosion? So what is the chemical corrosion? Is the chemical corrosion, this type of corrosion mainly occurred through the direct chemical action of environment or atmospheric gases like oxygen, halogens, hydrogen sulfide, sulfur oxides, nitrogens, anhydrous inorganic liquids. These are all responsible for the corrosion of the metals. So chemical corrosion is nothing but so this type of corrosion mainly occurred direct chemical action. Whatever chemicals present in the environment that causes for the corrosion is called the chemical corrosion. Okay. So whatever chemicals present in the atmosphere and environment or causes for the corrosion is called the chemical corrosion or dry corrosion. So these chemical corrosion or dry corrosion sub-classified into three categories. One is the oxidation corrosion. Second one is the corrosion by other gases. Third one is the liquid metal corrosion. So whatever these chemical corrosion is classified into three types. One is the oxidation corrosion, corrosion by other gases, liquid metal corrosion. So one by one we discussed in depth then you can easily understand the oxidation corrosion mechanism behind the chemical corrosion. Okay, next slide. Next slide is coming to the oxidation corrosion. So oxidation corrosion, what is the definition of the oxidation corrosion? Oxidation corrosion means in the name itself is there. So mainly this corrosion occurred by oxygen. Very easy. So whatever direct oxygen of oxygen at high or low temperatures on the metal surfaces in the absence of moisture. Remember that one. This word is a very important because in the absence of moisture only. If the presence of moisture, that is coming under the another type of corrosion, that is called the wet corrosion. So this word is must use absence of moisture, that is called the oxidation corrosion. So once again I repeat that one. So whatever direct action of oxygen at high or low temperature on the metal surfaces in the absence of moisture is called the oxidation corrosion. Some of the metals, silver, iron, platinum, are not oxidized because these are noble metals. Or noble metals means is inert metals. Inert means is a where less oxidation will be takes place. So what is the mechanism will be involved in the oxidation corrosion? Generally, already in the previous slides we discussed whatever isolated pure metals are thermodynamically unstable. Whatever isolated pure metals are thermodynamically unstable. The unstable metals are loses their electrons. That process is called the oxidation. During this process, liberate the metal ions and electrons. For example, this metal will be, I am taking this metal, for example, any metal. This metal, for example, I will take the iron metal. This iron is isolated from the iron ore, that will be unstable like that one. This unstable metal will be lose the electrons and liberate the Fe+2 ions like this one. So means this process is called the oxidation. Oxidation. Here the general we take it metal and liberate the electrons or lose the electrons. This process is called the oxidation or losses of the electrons and liberate the metal ions. Here the liberated electrons from the metal. This is the very important. The liberated electrons from the metal that will be consumed by the environmental oxygen. Environmental oxygen to convert to the oxide ions. Oxide ions. This process is called the reduction process or electrons, gain the electrons. Here the taking the electrons oxygen. So this process is called the reduction. The net reaction, the electrons will be cancelled. So the net reaction, metal and react with the oxygen, 2M plus and 2O2 minus 2 oxide ions are there. These two will be combined to form the metal oxide. A metal oxide layer is nothing but a rust. So means rust is formed like this one. So we can discuss in the next slide. You can clearly understood with the diagrammatical point. So here I am taking the one metal total. This is the metal. Metal will be taken. So I draw the with the different color metal surface. This is the up to this is the metal will be there. Metal is there. So metal will be taken. That metal already I told that metal will be liberate the metal ions, whatever metal ions plus liberate the electrons like that one. The liberated electrons, whatever the liberated electrons traveled across the all directions to metal surfaces. The liberated electrons traveled across the metal surfaces. Whatever the metal surface will be, electrons will be available like this one. In the metal surfaces, in all corners, all areas, is the electrons will be available. That electrons are consumed by the atmospheric gases. Remember in the previous slide I explained that one. The electrons at the surface, the atmospheric gases, oxygen. We are discussing the oxidation corrosion. So that the oxygen will be consumed by the electrons to convert the oxide ions. So means oxygen will consume the liberated electrons from the metal to convert the O minus to oxide ion. So means at the surface oxide ions are there. So in the metal already liberate the metal ions. Metal ions. These two oxide ions, anions, and metal ions, cations, these two will be moved together towards each other. So means metal ions will be towards across the metal surfaces, and the same oxide ions will be moved to across their directions. Where these two will be meet? Where these two will be meet? For example, this O minus 2 ion is moving like this one, and M plus ion will be moving like this one, where this place is these two will be combined. So in this place a rust is formed. In this place rust is formed. So means where these two ions meet, in that place rust is formed. Okay, so this is the mechanism behind the oxidation corrosion. So from the oxygen, oxide ions will be generated. From the metal ions will be generated. These two will be, mobility will be takes place, where these two ions will combine. That place is rust is formed. Here the another question will come. So which ion will be move fast? Here the anion will be there. Here the cations will be there. Which ion will be move fast? Either cation or anion. So that question will be arise. Generally, cation will be lesser size is there compared to the anions. That's why cations will be move faster at the surface of the metal. Cations will be more faster than the anions, because due to the only reason is the anions are a bigger size compared to the cations. So once these cations coming to the metal surface, so anions, whatever O minus 2 at the surface will be there, easily combined to form the rust. So rust product will be obtained with these two ions. Okay, you understand this? What is the mechanism behind the oxidation corrosion? Okay, now we move to the another topic, another step. So for whatever that one, so means the on the metal surface rust is formed. So on the metal surface rust is formed. On the metal surface rust is formed. Nature on the next one, nature on the oxide form, whatever oxide form plays an important role in the oxidation corrosion. So there are different types of oxide layers are formed. We discussed one by one. For example, if the obtained metal oxide is a stable. So means here clearly I will explain that one. This is the metal, any metal that will be react with the oxygen in the presence of either higher temperature or lower temperature in the absence of moisture. Absence of moisture to produce the oxide layer. So here the whatever lines, so that one is the oxide layer. So that oxide layer is a stable. If the oxide layer will be a stable, remember that one. The obtained the oxide layer on the metal surface is a stable. There is no further corrosion takes place, because here one comparison will be explained clearly. For example, I am taking the iron metal, another metal I am taking the aluminum. Both will be react with the oxygen, because we are discussing the oxidation corrosion. So both will be so here the form the Fe2O3, whatever Fe2O3 oxide film is obtained in the aluminum also rust will be formed. This will be Al2O3 oxide film is obtained. But coming to this point, iron will be more corrosion, or iron is faster corrosion than the aluminum. Iron is faster corrode than the aluminum, because aluminum, whatever obtained the aluminum oxide layer is tightly bind with the metal surface compared to the iron oxide. So means this aluminum oxide is tightly bind as a tightly adhering with the metal surface. So means that is impermeable to the further attack of the oxygen. Here is whatever obtained the Fe2O3 loosely bind or loosely bind. Easily further oxygen will be attacked. So means in this case more corrosion takes place. In this one a less corrosion takes place. Okay. So whatever the stable oxide layer that will be explained, further corrosion takes place or prevent the further corrosion, we clearly explained on that one. Coming to the another category of the oxide layer. If the obtained the metal oxide is, unstable, metal oxide. So means here once again take the metal that will be react with the oxygen in the presence of air, that will be form the oxide layer. That obtained the metal oxide layer is unstable. Unstable means easily decomposed. Unstable means easily decomposed. So once again the obtained the metal oxide layer is easily decomposed. Once again the fresh metal surface will be obtained and remove the oxygen. Mostly this type of corrosion happen in the noble metals like silver, silver and platinum undergo this type of corrosion. Okay. So coming to another type of, we discussed that one, volatile oxide layer. So here the, remember that one, another one is the volatile oxide layer. Volatile oxide layer. The obtained the metal oxide is volatile. So this is the metal that will be react with oxygen in the presence of either higher temperature or lower temperature. In the absence of moisture, the metal oxide layer will be obtained. The metal oxide layer is the volatile. What is the meaning of the volatile? Means easily evaporated. Volatile means easily evaporated. So easily evaporated means once again the obtained the metal oxide is easily evaporated. So once again the fresh metal surface will be exposed. The fresh metal surface will be once again react with the oxygen to produce the volatile metal oxide, and thus that will be evaporated and fresh metal will be exposed until total metal will be corroded. Remember that one, until total metal will be corroded. Total metal will be corroded. So means in this one easily evaporated. The best example for this one, molybdenum oxide. Because this is the molybdenum metal to react with the oxygen to produce the volatile metal oxide of MOO3. This is easily evaporated on the metal surface. Easily evaporated means once again fresh metal surface will be obtained. That will be once again react with the oxygen to the once again evaporated. Once again fresh surface until total metal will be corroded. Okay. Coming to the another one, porous oxide layer. If the obtained the oxide layer on the metal surface is the porous. What is the porous means? Porous oxide layer means, the porous means mostly say cracks, gaps or holes. A small holes are there. So means gaps are there, holes are there, or cracks are there. That is called the porous structure. So if the obtained metal oxide layer is the having these gaps, cracks or holes, it provide the further oxygen. So easily further oxygen will be attacked to the metal surface, underlying the metal surface. So easily further corrosion takes place. So this type of metal oxide will be occurred mostly in the alkaline earth metals and alkaline metals. So we discussed the different types of oxide layers occurred on the metal surface. What corrosion will be prevented or further corrosion takes place. This will be discussed in this one. So next one. This is the whatever chemical corrosion. The corrosion by other gases. Another topic is the in the chemical corrosion is the corrosion by other gases. So means in the previous slides all are discussed only with the oxygen. So metal react with the oxygen, environmental gas of oxygen. What are the corrosion products are obtained? We discussed. But other than corrosion, other than oxygen, there are a lot of gases will be available in the atmosphere or environment other than oxygen. Sulfur related oxides, halogens, chlorine, fluorine, bromine, whatever, hydrogen sulfide, carbon dioxide, carbon monoxide. These are all will be available in the environment. If other than oxygen, these gases will be react with the chemicals, what type of corrosion will be takes place? That is coming under the corrosion by other gases. So the ones these also causes for the corrosion, chemical corrosion, but this type of corrosion mainly depend on the reactivity of the gas. So this point are important, this one. So means here the reactivity of the gas very important. For example, the best example you take it. Here I am taking the tin metal. Tin is the SN metal. This is the silver metal. I am taking the another silver metal I am taking. So both will be react with the oxygen. In the environmental gases of the halogens will be present, that will be react with the chlorine. Here the chlorine. Here formed the whatever here tin tetrachloride. So means HNCl4 is obtained. So here obtained the silver chloride, silver metal, that will be obtained the silver chloride. So means silver chloride. So different metals react with the same gas. So to update or to produce the different whatever compounds, tin tetrachloride and silver chloride on the metal surfaces. Coming to this one, the obtained the SnCl4. This is the very volatile compound. This is obtained the very volatile compound. Volatile means easily evaporated. So means easily evaporated means once again metal surface will be exposed to the environment and once again react with the chlorine. Once again to form the SnCl4 on the metal surface. That will be continuous until the total metal will be corroded. Clear the point? Coming to this one, the obtained the silver chloride. The obtained the silver chloride. This will be a non-porous structure. Non-porous structure means no gaps, no holes, no cracks, nothing is there. So means that silver chloride is tightly bind with the metal surface. That will be tightly bind with the metal surface. So means impermeable to the oxygen. So oxygen did not enter to the metal surface, not oxygen. Chlorine did not enter to the metal surface. So means this will be a tightly bind with the metal surface. Non-porous oxide film, non-porous film is obtained. That's why in this case, is further corrosion will be prevented. Further corrosion will be prevented because the obtained silver chloride film is tightly bind with the metal surface. But here volatile tin tetrachloride is obtained, easily evaporated. That's why here the allow the further corrosion. This is the mainly a reactivity on the gas, on the metal, different metals. Okay, so this is the corrosion by other gases. So last one in the chemical corrosion. Last point is a liquid metal corrosion. So generally this will be happen in the most of industries. Liquid metals, liquid molten metals will be passed through the pipes. In the most of the industries are working, some of the liquid molten metals will be passed through the pipes. That pipes will be iron pipes or steel pipes. Different pipes are using for different purposes. If some of the, for example, liquid metals like mercury, this will be passed through the any metal. That metal will be penetrated this metal or dissolution of this metal to form the amalgams. So means this is the one type of corrosion. liquid metal easily dissolves most of the metals by forming the amalgams. So automatically this metal will be corroded. For example, mercury will be passed through the zinc pipes. This is the zinc pipe. Once the mercury will be passed through the zinc pipes, zinc total will be dissolved and form the zinc amalgam. If the mercury will be passed through the copper pipes, copper will be totally dissolved. Due to the penetration of the mercury, the copper amalgam will be formed. So means here the mercury is the more corrosive nature. That's why mostly we are using the or storing the glasses mercury. So thermometer also mercury will be in the glasses system. This will not pass through the metallic pipes or allied pipes. This will be more dissolution or more penetrated by the metals and form the amalgams. అందుకే మనకు తెలుగులో ఒక సామెత ఉంటుంది, పాదరసం లెక్కన యాక్టివ్గా ఉండాలి. మీనింగ్ is the mercury is that much corrosive nature is there. Mercury more corrosive metal. So పాదరసం లెక్కన యాక్టివ్గా ఉండాలి అంటే that is the one of the సామెత ఉంటుంది తెలుగులో. Okay, so this is the topic of the chemical corrosion. If any questions, please ask me, not a problem. I will clearly explain. So wherever questions are there, please ask me without any hesitation. Thank you very much. Thank you very much.